In the name of God, the most gracious, the most merciful. Today, God willing, we will discuss the subject of blast-resistant buildings. As well, we will discuss how to calculate the loads on it, whether statically or dynamically. For the second lecture today, we will give a very simple introduction to facilitate the next lectures after that. A simple introduction. We will take a look at the basic elements of how to calculate the loads of the blast load on the structure. And we will also quickly get to know the basic parameters, which are represented in both TNT equivalency and scale distance. Then we see the types of loads that come on the instrument through two views, either a view called load or to be unconfined explosion. There is a difference between the two. Confined explosion, I see if it is fully ventilated or partially ventilated, or fully confined, but the unconfined explosion is the explosion of the building. And free air burst or surface blast. Let's see this in detail until we see it in more detail in the upcoming lectures, God willing. The blast load calculations and structure, which is the main focus of the whole course. Here we will start working with static, how to calculate it as an equivalent static, and of course, while we explain, we will say the parameters that will be used in dynamic as well, but as blast loss calculations and structure, whether static or dynamic, the parameters are the same, but in the end, there will be a time history curve for dynamic and an equivalent method for static. What are the things that will go into static and dynamic together to get my curve or make it an idealization? The first thing is the blast load basic parameters. In order to get the load that affects the building, I must have two main parameters, the TNT equivalency and the scale distance. We will see them exactly. If I get these two values, I will get about 70% of the information that I want, because after that, the rest will be static. As we will see, these are the two most important things. And they are very easy, by the way. In order to get them, you will find them very easy. You see the load. We make a parameter for any explosive substance in the world. We get its equivalent as TNT, because all curves are dependent on TNT and also the distance. Today, the car that explodes at a distance of 100 meters, and there is another car at a distance of 50 meters or 25 meters. So there must be a scale distance in order to get into my curve. I must have these two parameters in order to get all the information that I will use in my curve, which will be either static or dynamic. This is very important, guys. This is the most important thing in our topic today. After that, I see the blast load categories. What do we feel now? We feel whether it is confined or unconfined, which means that if it is a confined explosion, it can be a fully ventilated building, which means that the building is completely open. The building is completely open, which means that it can be placed left and right, and the explosion will find a way to go through it from beginning to end without any obstacle in a certain direction. In the direction of blowing, the second type is partially ventilated or partially confined, which means that there is something between the two. Either it is completely closed or completely open. There are some openings from which a part of the explosion can come out finally. The third type is fully confined, like shelters, which means that the shelter is completely closed from all sides. Even if there is a window, it will be a wide window. So this is called fully confined, of course. I am talking about these three types. If the explosion is from inside the building, there is another classification, which is the classification of the loading situation itself. For the building, we call it unconfined explosion, which means that either the explosive loading is higher than the building, which means that the explosion is far from the building in the sky above, but at a certain height it affects the building, so its waves come from above the building. The shelter is the most exposed thing, and the side walls. There is no such thing as a front or back, so the explosive loading is higher than the building from above, and its waves descend. It affects the whole building from above and from all sides. In the second part, there is something called air burst, which means that the explosive loading is at a certain height, a little higher than the building and close to the ground. So it is a little higher than the building, of course. If it is multi-story, it is not a problem. I mean, higher than the building, meaning higher than 2 floors, for example, 2 or 3 floors away from my building. If it is multi-story and also close to the ground, this means that it is close to the ground. Not like the previous one, this is called the angle of incident, where we calculate the load resulting from it based on angle of its impact. So this is called the air burst explosion. The third and last type is the surface blast. What is the surface blast? The surface blast is when the explosive loading is placed at a height of 1.5 to 2 meters from the ground or close to the ground, which is the most common case. And you can say that this is our job. This is the job. When someone tells you to design this building for the next blast load effect, then you use this type. Why? Because most of the work is supposed to have a car that will stop at a certain distance and the car will explode. So most of your work will be on the surface blast, which will be very close to the ground, and it will be placed at a height of 1 or 2 meters, of course. Thank you for participating in this session. Should you have any questions or feedback, please feel free to reach out to me via my Facebook page, LinkedIn profile, or by leaving a comment below this video on my YouTube channel. Best regards.